In the relation series, I already discussed what is relation, properties of relation like reflexive, symmetric and transitive, NR relation, how to represent relation like 0, 1 matrix and diagram. Next I will discuss closure of a relation. We have a relation, suppose it is not reflexive, then we can add some order pair to make it reflexive. So we can say that new relation is the closure of that relation. So introduction, let R be a relation on set A. R may or may not have some property P. P can be reflexive, symmetric or transitive. If there is a relation S with property P containing R such that S is a subset of every relation with property P containing R, then S is called the closure of R with respect to P. So we have a relation, let R is not reflexive, then we can add some order pair, let after adding it is S and S is reflexive. So we can say S is the closure of R with respect to reflexive. Suppose we are adding some order pair to make it symmetric, then we can say it is symmetric closure. Suppose we are adding some order pair to make it transitive, then we will say it is transitive closure. Closure, the relation R, let R contain 1, 1, 1, 2, 2, 1, 3, 2. On the set A contain 1, 2, 3. This relation is not reflexive. So what we will do to make it reflexive, we can add 2, 2 and 3, 3. So the new relation having 2, 2 and 3, 3 order pair called as reflexive closure of R. We can add some more other pair, but minimum it should add 2, 2 and 3, 3. Because this relation contains R is reflexive and it contains within every reflexive relation that contain R, it is called as reflexive closure of R. So for reflexive closure, we are adding all the diagonal. We can say R equals to R union diagonal order pair. So diagonal order pair means A. Like 1, 1, 2, 2, 3, 3 in this set are the diagonal order pair. Now example 1, what is the reflexive closure of the relation R equals to AB, A less than B on the set of integer? For reflexive it should be AA. Here what is A less than B is given. So what we can do, we can add equal, means A less than B, or we can say A equals to B. When we will add A less than equals to B, then it will be reflexive closure. So the reflexive closure of R is R union diagonal relation. Diagonal means equal. So we can say A less than equals to B will be its reflexive closure. Next we will see symmetric closure. Let we have a relation 1, 1, 1, 2, 2, 2, 2, 3, 3, 1, 3, 2 on 1, 2, 3. And this relation is not symmetric. Now to make it symmetric, we can add some order pair. Like 1, 2 is there, so we can add 2, 1, then 2, 2, 2, 3, 3, 2 is already there, 3, 1, we can add 1, 3. So after adding 2, 1 and 1, 3, it will be symmetric. So you can say this new relation is symmetric that contain R plus 2, 1 and 1, 3. So the new relation called as symmetric closure of R. So to make it symmetric, we are adding 2 more order pair, 2, 1 and 1, 3. So that new relation called as symmetric closure of R. The symmetric closure of relation can be constructed by taking union of a relation with inverse of that, like R union R inverse. We can say R inverse equals to BA, whereas AB belongs to R. For reflexive closure, we are adding the diagonal order pair. Here we are adding the inverse of that relation. Now let's see one example. What is the symmetric closure of relation AB, A greater than B on the set of positive integer? So what we will do, AB is given, we will also add BA. The symmetric closure of R is the relation R union R inverse, and R given is A greater than B, AB union BA. R inverse will be BA, A greater than B. And here A is not equals to B. we simply add B a order pair and A greater than B, then this will be symmetric. Next we will see transitive closure. Suppose that a relation R is not transitive, how we can produce a transitive relation that contain R such that new relation is contained within any transitive relation. Consider the relation R. R contain 1, 3, 1, 4, 2, 1, 3, 2 on the set 1, 2, 3, 4. This relation is not transitive because it doesn't contain all the pair. For transitive, if AB is present, BC is present, then AC must be present. Here it doesn't contain all the pair of AB, BC, AC, so this is not transitive. So to make it transitive, we'll add some order pair. Here 1, 3 is given, 1, 4 is given, 2, 1 is given, 3, 2 is given. So 1, 3, 3, 2. We'll add 1, 2, then 2, 1, 1, 4. We'll add 2, 4, 1, 2, 2, 4, 1, 4 is already there. Now after adding 1, 2, 2, 4 is a transitive. Before there was 3, 2, we added 2, 4, right? 3, 2, 2, 4 means we need to add 3, 4. We need to add one more order pair, that is 3, 4. After adding 3, 4 is a transitive? Yes, now it is transitive. So after adding the new order pair, you may need to add some more order pair. Like this process will continue. So finding transitive closure is not simple like finding reflexive closure or symmetric closure. You need to work more. The transitive closure of a relation can be found by adding new order pair that must be present and then repeating this process until no new order pair are needed. So this can be done by Warsaw algorithm. We used Warsaw algorithm for finding transitive closure. I already discussed Warsaw algorithm in dynamic programming of algorithm. Just go through that lecture. I'll give the link in description. So in today's lecture, I discussed how to find reflexive closure, symmetric closure and transitive closure. In next lecture, I will discuss paths in directed graph. If this lecture is helpful for you, please like, share and subscribe. Thank you.